it different? In other words, what did all of those other data sets I just talked about have in common? What kind of data did all of those appear to be?
Previous paths expected.
Say that again.
Pretty much it had different previous paths.
Oh!
In time, they're always the same.
Oh, thank you, Randall, for that. That's fantastic. I wasn't thinking of it that way. All of those were based on, except for the measurements of the arms and the wrist. Very good, dude. I wasn't thinking about that at all. So except for the measurements of the arm and the forearm, they were years in the past, measuring up to the present. That was just, actually, the only reason that was the way it is, those were the data sets I found. And as a matter of fact, the South Sister bulge data that I'm collecting is the same way. I've got year after year after year. And the reason those were done in the course of years, the pattern didn't show up for years. I had to look at it in that broader scale to actually see a pattern. So it's still time. Thank you. Very, very good point. It's still time, though, whether it's seconds from 0 to 10, if you will, from this, or years. So that's kind of consistent, actually. But thank you for bringing that up. That is a difference, an apparent difference that really isn't that much of a difference. It's just in the scale of the pattern versus small versus large.
Independent versus dependent.
And each of these has that, doesn't it? Thank you, Francis. They're similar in that way as well. Everything has an independent variable, which in this case is time, like the other ones, and a dependent variable. Very, very nice. We call X and Y. No, Aaron, go ahead. Put his hand down.
Each one of these, you showed a linear graph.
Last week, the data we were looking at, I cherry-picked the data because the data, if you will, trended upward. It rose and ran. Yeah, sure. It rose and it ran at roughly the same rate, didn't it? For the life insurance, it was about, I think it was like 1.5 or 1 million people per year, and it stayed about 1 million people per year. Mount Bachelor, I think it was $1.50 a year, if I remember correctly. I'm probably remembering this wrong. $1.50 a year, $1.50 a year, $1.50 a year, until they Googled the actual ticket price nowadays, which bucked that trend. But for 80 years or whatever it was, or 40 years, it was $1.50 a year, $1.50, arguably the same. Same as, it was ticket price, and Facebook was the same as well. I think it was like 400 words per year. They keep picking up 400, which is amazing, because they limit what you can type. But they just keep adding their Facebook privacy policy, which I think is adorable. Twitter does the same thing. How about here? How about here? Is the rise and the run the same here as we go from data point to data point? Now it is tricky. It is tricky to see in this format right here, because what was similar in the data as I gave it to you last week, these X values, in this case the time, these guys were going up relatively in equal increments, 0 to 1, 1 to 2, 2 to 3, 3 to 4, or jumping by 2s, 2, 4, 6, 8, 10. So these are a little bit messier here. And the reason it's messier is because these are the ones that are consistent, 0 to 25, 25 to 50, 50 to 75. But even knowing that, does this data appear to have similar rises and runs? We know the rises are the same over here, 25, 25, 25, 25. These are all, the rises are all 25. Are the runs staying consistent? Are the runs staying consistent on the left-hand side? What do you think? I got a couple of heads shaking no. I think I heard one yes. Okay. If the runs were staying consistent, why did I get into the arrow tuck at the beginning? Was it just to make you laugh? Kind of. I tucked into the... What did aerodynamics have to do with anything?
The drag.
Drag. Cut down drag. Which is going to do what?
Slow down your speed.
Slow down my speed. Which is doing what as I go from the top of the hill to the bottom of the hill? Well, then you just told me that the rises and the runs are the same. Because you said my speed was increasing. Right? If my speed is... Did everybody kind of agree that my speed is increasing as I'm going down the hill? I think that's obvious. Due to what?
Gravity.
Gravity, yes. Gravity was making me go faster. Anybody's ever rolled a ball down a hill or ridden a bike down a hill like I just did, depending on the size of the hill, the tilt of the hill, things like that, your speed increases to a point. Chad, you asked about terminal velocity early. You asked, is there a speed beyond which you cannot go? I'm sure there is. I don't know what it would be. I'd have to know the friction coefficient on my bike tire. I've gotten my other road bike up to 60. And that was surreal. I'm never going to do it again. It was scary as piss. I just sit up, I kind of sat back, I looked down, the speedometer was right there at my handlebar, and I was going down. It was in Delaware, actually, of all places. I've only gone 52 coming out from Bachelor, which was surreal enough. But I looked down, I remember seeing it go to 60, and I'm like, okay, don't fall. I put my head back up, and what was amazing was putting my head back up slowed me down to 50. Just bringing my head up and creating that much drag. And then Going like that, 45, and then sitting back up to 40. Once you're at 40, like, okay, everything's fine. But like, it was insane how fast you pick up that speed, and it's all due to gravity. I wasn't pedaling. Notice I wasn't pedaling at this experiment. I started with my foot down to 6 o'clock position every single time, and I tried to stay there for the duration of the ride. I think I may have rocked back to 9 and 3 for each time, but gravity. And you can see that, look at how long it took me to go from 0 to 25 feet. 3.3 seconds, yes? How about from 25 to 50? Ish? About 1.5 seconds? How about 50 to 75? Yeah? How about 75 to 100? 0.7? How about 100 to 125? About 1.1, somewhere there. It's a little noisy. 125 to 150? 150 to 175? 175 to 200? You see what's happening? It's a little noisy. But generally, it took me longer to cover 25 feet in the beginning than it did at the end. That doesn't sound like linear to me, does it? It might be parabolic. I want to look at it, though. I want to look at it. It's definitely, the rise and the run are not constant anymore, are they? No, they're not constant anymore. Here's what I want you guys to do. Take the data, put it into your L1 and L2, and get a scatter plot for it, okay? Use your TIs. I mean, Excel's great, and I'm glad we have Excel to play with. But we don't have Excel at our desks, unfortunately. We have our TIs. So if you need your little booklet helps, of course. Get your data, L1, L2, get a scatter plot, let's play. Okay, I'm going to turn this off while we do that. I want to watch